Dear colleagues, we have to start our last session this day. And our agenda is as follows. So we will start with three short talks. Our panel is constituted by three short talks by three people from different subject domains. First will be Viktor Dudarev from, he's a representative of material science. The second will be Oleg Malkov from astronomy. And the third will be Alexander Fazliyev from earth sciences. So the rules are as follows. So for every talk, it will be very short talks, about 3 or 5 minutes. And after these talks, we will proceed to the discussion. So we have a list of questions, which is what was prepared together by Peter and Leonid, and that's quite a list of questions to discuss, mostly concerning FAIR and EOSC. And well, we cannot waste such a chance, well, to attract our invited speakers who are expert in data research infrastructures in Europe, so well, to force them to answer these questions, especially urgent for Russia. So let's start our panel. The first speaker is Viktor Dudarev. He's a representative of material science. Viktor, the floor is yours.
Thank you very much. I'm very glad to be here. As Sergey already said, I am being a representative of material science. So basically, I'm working in Baikov Institute of Meteorology and Material Science. And at this very organization, we are developing a number of databases on properties of inorganic compounds and their properties. So basically, within our organization, we are dealing with such databases as phases. So it's a database on phase diagrams of inorganic compounds, diagram, band gap. This database describes basic structure and forbidden zone width for some inorganic materials. Elements database describes basic properties of elements described in periodic table. And crystal database, it is a database on special substances with acousto-optical, electro-optical, and non-linear optical properties. So within our organization, we are trying to integrate information from our databases and from databases abroad as well. For example, it is Atomwork database from National Institute of Material Science, which is situated in Tokyo, Japan. So basically, we are gather data from several databases. After that, we somehow aggregate this data and feed them to machine learning algorithms to develop some regularities in chemical information. And after that, we can make some prognosis on properties of undiscussed or unknown substances. We can evaluate their properties, and that's why we are interested in participating in FAIR initiatives. So we are searching for some specialists from other countries, particularly from the European Union, from the United States, to exchange materials data to make better prognosis. So basically, I won't take a long time. So.
Okay, thank you, Victor. If we have some urgent questions right now, okay, let's postpone all the questions to the discussion. So thank you again, Victor. I'm sorry for my mistake. So the next talk will be given by Dana Kovaleva. So he is a representative of astronomy.
I'm here instead of Oleg Malkov, who is my chair, and he can make me speak instead of him. I shall talk about the database of binary stars, which in the frame of FAIR paradigm, the BDB is a database we develop, so I shall start with the statement that FAIR principles are very close to astronomical community. Actually, astronomical data has been considered as reusable since the very beginning of astronomy as a science, because they are irreproducible in principle. So we pay significant attention to the storage of the data and to provide successful reuse of them. And since the beginning of 21st century, the paradigm of virtual observatory has prevailed in the astronomical community, which basically follows the FAIR principles. The idea of virtual observatories is that all astronomical data sets that were obtained by any astronomical group or any astronomer in any investigation taken with ground instruments or obtained by a space mission should be seamlessly accessible to any other researcher. This requires, I would rather say, development of technical standards. To develop these standards, to discuss them, and to support moving astronomical data toward general access. The International Virtual Observatory Alliance has been established. The Alliance, one of important part of Alliance activity is to develop a suite of standard data models described of data that should be described by unified content descriptors and accessed via standardized data access protocols. Well, actually, when the virtual observatory project has just started, it was moving very successfully, and all the simple fields were covered by data models and data access protocols rather quickly. These were photometric data, spectral data, images, astronomical images, observation cores, and so on. However, there are some fields in astronomy that are difficult to represent so as to provide seamless access. One of these fields are binary and multiple stars. Binary and multiple stars are very numerous astronomical objects, and moreover, they are very important scientifically. However, they are complicated because they are observed by different methods and characterized by very inhomogeneous data sets. And moreover, when you observe multiple and binary stars by different methods, you often observe different entities. This is why the data for binary and multiple stars were not so well accessible by request, so not so well findable as we would want to. The purposes of creation of the binary star database was to join all data and metadata from astronomical catalogs and databases of binary and multiple stars of all observational types on all the entities that exist in the frame of these stars. and to provide interoperability for this data and to provide interoperability with the virtual observatory. This work has been started in Besançon Observatory in France, and since I might be mistaken, was it right? The data is right? The development and maintenance of the database was moved to Institute of Astronomy in Moscow. Since the time we develop and maintain and support BDB, we do it in collaboration with the colleagues from Institute of Informatics Problems, and I would like to mention Leonid Kalinichenko and Nikolai Skvortsov here. What we did, we created the conceptual scheme for the binary stars data, which includes 3 types of entities in the frame of binary and multiple stars, which are system, pair, and component. This helped us to establish proper links between entities and relevant data of different catalogs and databases. The index catalog for the BDB is named Identification List of Binaries, and it includes all the identifiers for all the entities that help glue together all the data for binary and multiple stars. Each entity in this catalog has a unique identifier. Here is an example of how the list of identifiers for just one system looks in the ILB. Well, I don't think if it's readable, it is readable. Today the BDB is accessible at this link. What are our tasks today? We develop the methodology of resolution of multi-component entity characterized by a set of parameters of heterogeneous components to improve the identification of components in multiple stellar systems. And our primary task here is to provide complete VO interoperability, because as for today, our interoperability options are still limited. And here is a screenshot for some object, which is Alpha Geminorum. Thank you.
Okay, thank you, Diana. Do we have some questions right now? Okay, let's postpone it again. Don't mind. Okay. And our third speaker. Alexander Fazliev, who is the representative of Earth Science here.
Not only the science.
Okay.
First of all, I have said that I speak English only 1 or 2 times per year because I live in Siberia, and a foreigner is a very rare bird in our country, in our part of our So if I will be not correct, or maybe my accent is disturbed to your mind, so excuse me. In practice, we during the last 15 years solved 2 tasks in atmospheric science. First of all, there was a problem to organize the atmospheric portal on atmospheric science. Atmospheric science is multidisciplinary science, so we have first problem was integrated different resources from part of this multidisciplinary science. It was very difficult problem, but after the end of this period, it was funded by the European Union, and we made our work with our partner from the European Union. It was all at 2004 years, 4 years, and we, after a few period, 2 or 3 years, understand that our methods and our solution of the problem to integrate the atmospheric science, different part of atmospheric scientists was not correct, and the impulse which cleared our mind was the appearing the semantic web language out. Because from our point of view, this approach and this language in particular give us a chance to integrate resources on this more abstract level of understanding of the science. And during last 10 years, we concentrate our attention first of all on the fundamental part of the atmospheric sciences, molecular spectroscopy, because most components of the atmosphere is molecules. Here is the schema of the information system, and the main principle is that the resources, information resources, separated on 3 parts: data, metadata, or information and knowledge or ontology. From here is a first column, and the second column is services or applications which use this data in our information system. And last column is the interfaces, the type of interfaces we use in this information system. So, as I said, main focus was on the ontology approach to the classification of information resources in spectroscopy. I will not say with more details. I will show only a few individuals and say a few words about the metric of this ontology. Here is the one of the, you know that the ontology has individual and classes and properties. There's 3 main components of our ontologies. This is one individual, its name, information sources, then there's so many symbols, and you can understand it if you don't know the bibliography of the in spectroscopy. But I demonstrate these individuals which describe the relation between for example, between 2 articles. What is the relation between 2 articles? First of all, we investigate the quality of these 2 articles relative one to other. So this scheme demonstrates how many each square is the individual. Arrow is S property, and in below you see that how many individuals may occur in this domain. It depends. N is the spectral bands. When the data spectroscopy data has a great volume, for example, for molecule of water, the number of transition is more than 500 million. And at that time, most the data about the methane molecule has more than 10 billion transitions. But transitions is grouped in the bands. It depends on the what kind of vibrations it has this molecule. And in fact, number of events might be more than 1 million. So you see that one individual will have more than 1 million components. And so there was a problem how process of this kind of the individuals which we generate in our system. Here is the second. This is the example of the one fragment of the spectroscopic ontology of informational resources. This is the resources of molecule. This is isotopologue of water. It's heavy water, deuterium 217 O. And first of all, you have concentrate the attention. This is small from the spectroscopic point of view ontology, because only axioms we have approximately 40,000 for one molecules. It's not big. It's not molecule which has a very greater amount of the descriptions. And second point is the expressivity of the this ontology, because what is expressivity and why is the aim to calculate or compute this quantity? When the amount of the ontology will be such more than 1, 2, 3. In fact, at that time we have only one our ontology of our organization. I didn't know about any other ontology. But in fact, in principle, from the point of semantic approach, when you choose the resources, you have resources which can be processed by not only researcher but agent. You have to understand what is the DL expressivity of this resource is. So here DL expressivity is shown on this slide. It's rather high expressivity for such kind of resources. This is other metrics of this ontology. This is three ontology: ontology information resources, spectral functions, and molecular transitions. It's not all ontologies. We have also ontology on state of molecules, bands of molecules, and so on. First of all, you see that each ontologist, when we compare these ontologies, we see that ontologies which has maximum knowledge base metric is ontology of transitions, molecular transitions. So you can estimate from this formula how many individual is. If you knowledge base ontology is defined as Z, where I is the number of ontologies, and C is primitive metric, which is equivalent to the number of classes of ontologies. So you see that the number of individuals is more than 1 million for these ontologies. From our point of view, technical point of view, it's most detailized information system with ontology constructed for the users. total volume of ontologies is approximately 80 gigabytes. It's not small because we have no any engine for processing such kind of ontologies. It's a problem for us. So, but we have possibility to process it because we have approximately 40 molecules, and the ontology is separated in independent for each molecule. So we can use only part of ontologies for definite molecules. Other system, I will say, just other system is devoted the climate system, climate and weather system. This scheme is equivalent of structure with spectroscopy. We have three layers of the system: data, metadata, and ontology. And but we have another application first of all, because climate is strongly dependent on the topological resources, topographic resources, and the list of tasks is different from the spectroscopy. First of all, in climate system, we have oriented our application to problems of making decision making. And during last 3 years, we achieved only one point. We create a database for two climatic problems. This is applied tasks in climate systems, and transform this data in the knowledge base, which we will use in decision making system. So that's all.
Okay, thank you. So I think now it's time to proceed with the discussion, and I propose to organize it in the following way. Let us put for our invited speakers the chairs near the screen. Виктор, можно попросить вас стульчик и третий еще стульчик я видел? So now, это для наших приглашений. Для панелистов, наверное, уже. Yeah. Could you please sit here? And Michael, please.
I can stand. I'm a chair allowed.
Okay. So actually, I opened a file with the questions which were planned to be discussed here within our panel and discussion. So, but that's not only question that we're able to discuss, but any question from the auditory is welcome. So my idea is to attract the auditory to ask our invited speakers, well, according to these FAIR and EOSC issues.
Well, actually, I think that we can be more generic as well. That not only discussing exactly the things what we are here, but anything else which came up today, which
Yeah,
I think
sure.
is relevant. And for me at least, for me the really interesting part is not really only to know what is happening in Europe. Of course we can try to answer anything what we know, but also that's how we can really build the engagement with Russia as well. So it is not, we are not planning this to be a Europe, fair is definitely not a European thing. EOSC is a little bit more, but it should not be too European, if I understand right. You can correct me. But it's. I'd like to see some question or some discussion on this. And what's your viewpoints on this? Nobody wants to answer.
It depends not only from researchers, but from administration level that is not here. So we can't tell their opinion.
Of course not. But think about what would be the. How would you like to organize this kind of thing? What would be a good way of finding? For example, Damien, who already left, presented all these different projects, and these are already funded. But in case of, and also in my project case, is that what we are looking for is a good way of building a conversation on these things that we do. We are not intending to do them in our own little corner. And as was also presented in all the presentations here, that there is a lot of activities connected to this in Russia as well. And so how do we build
I
this?
can tell our component, which is rather small in the scientific field. I operate in biology, in a very small part of biology. This is microbial culture collections. Microbial culture collections keep the examples of what was studied.
Yeah.
And what should be checked, what should be studied in more detail. So this is something specific, but this specific system has old connection to Europe and to the world. We are partners inside European culture collection system, and in September we conducted annual conference here in Moscow. We are partners inside the World Federation system, and we accordingly participate in some projects in Europe, in USA, in China, and if we speak about just fair, the first specific, most of culture collection cannot be fair. They are too poor. Almost the number of culture collection registered is approximately 700 all over the world. The number of culture collections that have own databases and registered globally is 122 just at the moment. It will be more. Maybe 10 or 30 more can be fair if we give them some method. Only the sample component, but this is only one side. At this talk, I am representative of the task to connect this system of culture collections to the knowledge of microbial data. And FAIR is very, very important instrument for this. But most of the knowledge is outside our access. We can only get information or sometimes try to write them. But anyway, if they are not there, we cannot change this. So only the central component, our central databases that aggregate information can be fair. All other parts are not fair. And fair description propose all components should be fair. This is simply for us.
Yeah, did I understand now that the reason why everything cannot be fair is mostly resources? Yes.
And we almost all the partners are not fair. This is very important.
This is a bad acronym. Yes.
We must understand that this is our life.
Yeah. But this is a question then, that how we can kind of, I mean, if this is a resource question, then the question is that is it worthwhile to become fair, first of all, for all of these things which are not yet, and you don't have the resources. And then, of course, it's about or can we convince somebody to give you the resources, or is it a thing which is needed?
There are some procedures how can we communicate.
Yeah.
Therefore, we contact only open system.
Yeah.
Closed systems are very expensive. We cannot pay for example, 100 databases that are closed. Licenses are too expensive. So only open databases, open system of knowledge can be connected. Otherwise, we have no money for this. And one more position, we cannot make principles of fair. We can only implement them. Implement in practical, real system that is rather old, and it was constructed in the center of the previous century, and it is growing bigger and bigger and more advanced. Nevertheless, it is rather stable. The data were collected for a long time, so they are not changed all the time. This is a very slow process. The data in different parts are very different. For example, I looked at 4 known culture collections: ATCC, DSMZ, BKM, and German GCS, and I don't remember. Very, very good culture collections. And I looked at one micro and compared 24 properties that were presented on all the 4 databases. Almost all the data were different. They were slightly different. For machine, they are not the same. Only 2 positions were the same. Theoretically, it could be 142 coincidences, but the picture shows only 2% the same. For each of them prepared the separate way. If we say that they are accessible, they are findable, but they are not integratable. So it's very difficult to change something inside them. But this is a process that should be somehow done. How maybe we should make some mirrors. What is what? It's not so clear how it could be done. We are working on this question, but this is a very slow process. Fair must be our instrument, but it's not quite clear how.
Maybe not integratable is not the right word. Maybe not interoperable right now.
Yes.
But we should make it.
We must.
Oh, sorry.
Well, just I think both comments that you made are related in that on one hand there's maybe limitation of resources, so it's hard to make things fair. On the other hand, you can see where maybe you're fair now, but where you need to be fair. There's a question of just prioritizing the process, I think.
But the process is not so clear. If we are looking what will be fair, we should have one description in many details. For example, what is policies? What is data management plan? The understanding could be absolutely different. I looked at the fair sharing database and looked what is the policy. I discovered only 3 policies.
Yeah.
All of them were written absolutely for human and not absolutely difficult to understand what is inside. According to the action plan, they must be document objects, understandable by computer. This is absolutely different level. The number of databases is 1,133, and only 3 policies. This is not balanced. It is impossible.
But this is also, I think, laying the pathway for the priority, right? So you can say right now there's only 3 of 100, or there's maybe 2 of the 114, which in your last example. But this is where it is now. And then the question is, given some amount of resources, what do you choose to do to increase the fairness in the next step within that budget? And then it's a very strategic question. It's okay, am I going to go for F? Am I going to go for A? I is going to be really hard no matter what. So maybe it's enough just to know that these things are there, and I will have the machine access them for me. I will do the integration and the interoperation myself for now. But that's then a target for you to come to later.
Before your decisions, there is one more level. If the fairness is the final goal, the optimal solution for me is to say, I am fair, and to do nothing. I will pay 0 money for fairness, and I will show that I am fair. This is a joke, but nevertheless, this have good background. Some company can make some very, very limited amount of job to show that, for example, we are go fair. There are some requirements what should be inside. We can do the minimal job just to be inside, and we'll show we are the partners of this great system. So we are the programmer, the researcher, the administrator is looking for minimal payment and maximum result.
If you allow me, I'd like to jump on your comment, because we can enter into very detailed discussions about how to implement fair data, but the basic question is, why would you implement fair data?
Yes. And there is one good reason.
And fair data is a means to something. And what is this something?
Yes,
And
can I show what? For us, the fair is the tools to integrate the background tools, to integrate some infrastructure inside your Slack. This is level 1. The level 2, this is the tools to integrate with the knowledge collected for our micros. If this is the instrument of fair, the final goal of fair, okay, we can make necessary steps just to implement this. But the final goal of fair, why it is should be done, this is the first question. And how, for me, this is the second question, how could we implement the fairness? I see many details, for example, 34 positions in application plan, for me, much more attractive than 15 positions in that were discussed today. They are more convenient to be written, implemented just for, to make background for integration. They are more instrumental.
thank you for your explanation. What I see in Europe is that the reason why probably fair data and EOSC are very much taken over, and this acceleration of the taken up of these two concepts, the reason for that, I think, is mainly embedded in the fact that the funders of research are very much interested in improving the efficiency of science. And efficiency of science means that with the same investment you get more results. And to get more results you need to accelerate the reuse of the data, of the codes, of the knowledge coming out of science. That's why I was referring to open science. We believe open science is happening, probably with different degree of maturity from one country to another one. And I don't know where Russia, the Russian Federation, is placed in this. You know better than I do. But we can see amongst the member states in the EU that there is a wide variety of maturity. So every country is starting from a different starting point. But still, the movement is on its way, and everybody wants to be on board in Europe. And the funders are very conscious about this motivation to have more impact with their investment. And that's why I think we have such a political commitment to EOSC. And maybe from a community point of view, we have such a willingness to absorb what these fair principles are and what the consequences are in terms of implementing them with their own specificities. Because fair data is something which can be defined at many levels. And I think 2 days was a kind of journey from a very broad picture to more and more specific views and being very much down to the reality of the researchers in various domains. And for me, this was very interesting to see this. I should not do this, the direction you like. But this way to see the reality of FAIR as a red line across all these levels down to the reality of the researchers was very interesting today.
I would like to add on this one that you can see also, I think that it was a very good example from astronomy. I think that astronomy is something which has done, the fairness has come a long way. I mean, it's been somewhere in the 80s or something, the latest that they started this. And I have a theory for this, and this is not only my theory, it's kind of obvious. The reason for it is that you needed very, very expensive equipment. And when you build something which is really, really expensive, which is not just your own little thing somewhere, suddenly your funders are really interested in what you actually are doing with it. And then that also leads to the fact that you really need to maximize your user base, and suddenly you really need to get all the astronomers in the world to use your data, because this is how, then you can say to your funders that this is the reason why you gave us 100 million. So, and then it really creates this. And this is when I'm working from the environmental research infrastructures. This is why we are pushed for FAIR, and it's kind of obvious for us because we have been paid quite a lot of money for it, and then the funders are really, and that's exactly the point what you raised, was that we need to, sometimes the efficiency comes from the fact that you are giving too much money, and then you need to really to make sure that it is used properly. And then this is not necessarily the case with the individual research grants, and there you need a little bit more stick from the funders.
Yes, you're actually right. We need rather extensive equipment to make real science. We have, well, it looks like a job, but it's not a job. The higher the level of support to the science, and in particular to the astronomy, in this particular country, the fainter the objects the astronomers observe. And in Russia, from 1/4 to 1/3 of astronomy is solar astronomy. It's a real situation, but fortunately we are in a rather good position because we are integrated in International Virtual Observatory Alliance, as Dana told you. So and plus I actually don't know close data sources in astronomy. Probably they exist. Probably it concerns minor bodies and solar system, dangerous bodies, but in stellar astronomy they doesn't. So we are integrated, and it means that we are not alone, and it means in particular that Alliance follow the FAIR principles, and we have to follow Alliance principles.
Exactly. And this is also the interesting thing in astronomy, which is the culture, which is that everybody, when you make something, you kind of automatically assume that everything what you do is open, all the data and so on, because it has been part of it. And then I've sometimes thought that somebody should really do, not me, I'm not a sociologist, somebody should really study why different groups, I mean, you can see in the Research Data Alliance that different sciences, which can be very close to each other, some of them can have this culture where everything is free and open, and then a little bit side from that one on another field, suddenly nobody shares anything. And it's sometimes, for example, I am not sure about this, but I get this impression that part of analytical chemistry, for example, is such that people don't share any of their kind of the data of experiments. Everybody has to do the experiments again and again and again and again, but it's just not a culture. And then in some other field very close, they might share everything. How this happens, I have no idea. Part of it might be that the funders have exactly forced them, or it might be just that people have realized that this is a really good idea. I don't know how this starts.
One more thing about astronomy that I think promotes sharing data and so on is that we have so many data and so few astronomers that there is nothing to keep in secret. There is no sense to have your data just for yourself because you would never have sufficient time to get everything from them. So it's better to share data and to have a large impact.
And also maybe because of the big facilities, which I kind of little bit touch on my talk as well, is that with big facilities you're living for a long time. And if you want to build something fair, I mean by yourself, if you're doing your own little research program, trying to figure out how to make this findable and interoperable and so on, without any extra help from outside, it's really difficult. Nobody's going to spend all the resources for them. But if you are an infrastructure kind of operation, which basically all the astronomy is, you can very well justify investing all that effort, making things interoperable and reusable, which is, you can see the benefit. But then in the case of some other fields, it's not maybe so obvious. I'm not sure how that one will. I think what was also mentioned about the EOSC, I think that in Europe at least that can help in a sense of being a buzzword as well. That in some fields that people then can start to say that why you are unfair, even though from personal point of view of the researchers or even in the organizations it wouldn't really make much sense, but you just kind of have to do it because it does it. I'm not sure how to do that.
Maybe I can add another dimension. I think fair data implementation is good within your own scientific community for sure, because it allows reuse and sharing within your community. What we also have in Europe at least is this trend towards pushing the communities to reach outside their own community. And this is linked to the innovation process. We would like to do science for science, because we need new scientific knowledge for sure. But we also would like to have impact of science on society, which means that we want to fund innovation. And you do innovation once you start sharing scientific data with other kinds of data, meaning socioeconomic data, for instance, or statistical data. I know the example of climate change, for instance. You can do purely scientific approaches in climate change, but once you want to develop climate services that will allow a municipality to take right decisions or a region to take right decisions in accordance to what the evolution of the climate at regional level might be, then you need to cross different kinds of data sets. And that's where fair data implementation will not only benefit your own community, but also benefit other communities. So that's another reason why we would like to go this way, try this way at least.
So this is an excellent point also, I think, because I can bring it back around maybe to a way to involve Russia in ongoing FAIR activities already. So in GoFair, I showed a picture of 20 different implementation networks from a range of domains. And so for example, I think that one of our two most advanced implementation networks are the Chemistry Implementation Network and the American Geophysical Union, which is, they have a project now called Enabling Fair Data. And so this is a United States American Geophysical Union, a very influential organization, but they have a 1.5-year project that involves publishers, funding agencies, data repositories and then universities and real data producers. And they're all in a room together trying to figure out the metadata standards and how they're going to go fair. So in July, I was with the Chemistry Implementation Network, and this was a group where you had the International Union of Pure and Applied Chemists, so IUPAC was in the room, CoData was in the room, several industry representatives were in the room. They were very interested in verifying spectral data, but this is a group now, the chemists are trying to figure out how they are going to go fair, how they can make chemistry data more routinely machine readable. The same thing is going on with the American Geophysical Union. When you attend both of these organizations, you see the questions that they pose for themselves are analogous. So decisions have to be made. In geophysics or in earth science, when it's time to describe organic compounds in the soil or inorganic compounds as atmospheric aerosols, why should the American Geophysical Union define a whole new set of ontologies again when the chemists are already doing that? So my job in Go Fair is to make those bridges. And what I would like to do in the next year is actually try to launch mini projects or pilots where I actually go to very different implementation networks, but I'm looking for cross-reactivity. So I don't know, we could, if solar physics is such a prominent type of astronomy in Russia, we can, I would imagine maybe there's links to physics or plasma physics that might be of interest. But even connecting solar activity to what's going on in the American Geophysical Union's project would be so interesting to show that connection. So one thing I would offer here as an opportunity is that any of the research communities in Russia right now could join or could initiate their own Go Fair implementation network. And Go Fair as an organization would be very happy to support and coordinate, because that's what we do. And we can not only facilitate the efforts, the needs of the Russian Federation, but we automatically are linking out to the other implementation networks that are doing almost the analogous problem solving in their own domain. Come to Leiden next Monday, and we'll do the metadata for machines workshop with Peter. Let's start there.
Yeah, maybe it is very much connected with this one. I am just, as I told also earlier, that what I'm a little bit worried about with this all these EOSC projects, otherwise great, but they are now being funded all in Europe. And what I'm afraid of, that we might end up in a situation where we are very much looking inwards, and you create your own standards and own things in there, and then they are not really applicable for some problems, or there is some fundamentally wrong for some sciences which maybe we haven't thought about, or some other reasons, historical legacy reasons or so on. So this is the thing where I really would hope to create this interaction. That when we get some sort of prototypes out through RDA or some other method, that we can really get feedback. And I mean, not only feedback which is like, yay, good, but also that this doesn't really work. And that this is, I think it's very important. I think, by the way, that these questions what Peter was far too specific. So
Yeah. These questions for concerning digital objects and persistent identifiers are a bit specific right now, because actually Peter ended the go-to meeting. So I think we can skip these questions. So do we think that we discussed somehow these general questions?
no, I think so. I'm not sure about. Well, I have a different list than you.
I realize, but I just grouped as on fair, I think we have maybe two small group of questions. The first question that I think, well, I'm sure that these questions concerning data models were inspired by Leonie. Well, both these questions, well, actually concerns this zoo of data models within fair infrastructures. So probably our invited speakers can comment something if there is some how should I put it, some movement to choose some unifying data models or to construct some data models that are applicable for data infrastructures, because I suppose it's impossible to use specific data model for every infrastructure. So,
what I can say is yesterday I was at a Bielstein conference in Germany. This is an organization that manages, well, I guess in the old days they were a compendium of organic compounds, but they do more like open science related things now. But it was a conference on open science in chemistry, and this idea now that I see it more often, that there's fair data, but there's also kind of like fair processes. And people are trying to figure out how to capture workflows with the kind of detail that would allow for the reproducibility of a computation, of a complex workflow computation. And it's really quite a different thing than just verifying a static data element. So I think for me this is kind of surfacing now as another kind of question. But I think,
and you have another group of questions.
But I think there's a growing. I think there's at least 2 or 3 models that I'm aware of languages that describe workflows that are trying to be applied in a fair context.
Okay.
So that's where I see unified models or unified language systems being used right now in the context of fair.
Yes, it's very important, and you can see concerning these workflows and data processing, there is 2 more questions about workflows and solving problems within data infrastructures.
Yeah, exactly.
Yes, and your comment partially answered these questions, but what I mentioned is some data models for data to be operated by these workflows. So these workflows have to operate some data extracted from different databases, and all these databases, well, they are always represented in different data models, and we have to make we have to make our data interoperable within our workflows. So, I think that Leonid tried to formulate these questions concerning this common unifying canonical data models.
Yeah.
Are there any candidates? Maybe RDF. But he preferred SQL, for instance. But we were wonder if there is some movement to consensus in this area.
I would say that not across all kind of fields of science.
Okay.
You can see in some fields of sciences that they are working more and more towards more consistent way. But it is. I don't think that it might be feasible to think in very short term, at least from my perspective. Is that you can, and it's also because the data is used very differently in different fields of science,
Okay.
and so it can be very challenging to do this. But It's usually is the typical answer to many problems is to create another layer on the top and say that it will explain everything. And then just end up with another layers on top of each other, or competing over layers. And this is how it usually is.
Okay.
But regarding the workflows, this is definitely one of these things. What, for example, in environmental field, what we are really aiming at is interoperable services. And interoperable services mean exactly this: that some of them are virtual laboratories, but it also means that data streams and processing activities have enough of interoperability between them. That in environmental sciences, at least inside our cluster, they work together. At least, let's say that what we can be quite certain is that inside the subdomains, so inside the marine sciences, things are probably going to be very much more interoperable than between marine sciences and solid earth, which even though they have interface, the interface is not so obvious, you don't necessarily need such interoperability. We have to see how it goes. Of course, one can hope that we end up with a canonical model for everything that really works, but not so certain of this.
So, okay. So I suppose it's fair enough for fair questions. We have some time, maybe I should say 15 minutes, maybe to discuss this
EOSC
question. So,
what is the state of EOSC at the moment? This is a very good question. You probably have better answer than I.
It's very easy to answer. We are going to start the implementation on the 23rd of November. Which is true. I mean, I'm joking, but it's true. I mean, we have...
First projects will be from the next year? Real projects.
So, projects we have already. The point is that we are still in a piloting phase. And we have about 20 projects, research projects related directly to EOSC, developing different aspects of EOSC, from the governance to the fair data implementation to the rules of participation that will govern how the transactions within EOSC will be governed. So there are many subjects that are currently developed by different groups and consortia in Europe. So that's what I call the piloting phase. But we will start the implementation phase for the next 2 years with a new governance structure that will be launched in November in Vienna. So the serious things will start from that time onwards. The target we have is to have by 2020 an EOSC with a new legal structure, with clear rules of participation, and with a progressive, gradual expansion in terms of number of research infrastructure that will join the EOSC, share their services, share their catalogs of services, share their data sets for the researchers. That's more or less the implementation roadmap we have.
okay.
Can you answer me one question though? I remember in the very beginning of EOSC, there was a lot of discussion that even though it's called European, it's not meant to be European, and the Americans were very keen on supporting this from the distance, not giving money, but giving some sort of moral support. What is the situation right now with this kind of initiatives?
Well, as I said in my presentation, it has a European focus for the time being. Now it's a stage approach, so we would like to expand beyond the research community and the research data to public sector data in the future, as well as to commercial data, but still with a European focus. While the fair concept and the fair dimension is global by nature. That's why we need such interactions on the fair concept.
Okay. Well, for instance, the second question concerns whether you have a clear understanding of architecture of EOS? Or it would be well the first stage of your project?
Well, it's a complex question. We have many concepts for data infrastructures.
Okay.
Because we have many research infrastructures being funded in Europe by different communities, by different countries, at European level. So we have many concepts that are existing already. Now, EOSC is not just a research infrastructure, it's a system of systems.
Okay.
So it's another level you have to address, and therefore there is no existing concept within the existing research infrastructure that can be directly imported to EOSC and translated into a system of systems. So I think, yes, we have many concepts, but we don't have yet a clear concept for this system of systems. And this is an issue that has to be addressed during the next 2 years.
And the third question is exactly why. The third question is why it should be system of systems.
Why?
As I understand, right?
Yeah, why it has to be distributed
Yeah.
in a heterogeneous system. Well, partly because I think now this is, you might have a but better understanding, but my perspective is this one, that most of the data and processing organizations in Europe, almost all of them, are funded by member states. And this is how they are run. And if you would instead come and say that no, you should close all your computing systems and facilities, and we instead build this great European one single system, this is not going to fly. First of all, nobody has the money for it, and second of all, it's not going to be possible, and it also isn't very smart. It's different things have different advantages, and building them together is much better than to try to build, let's say, a canonical computer center, which is the best possible solution for it.
When I read this particular question, I could see Peter in the background thinking about digital objects and digital object interface protocols. So would there be one sort of, waste of the hourglass that's giving structure to this otherwise, distributed thing at the top and bottom? That's what I thought I heard in that question.
I fully agree with your answer. I would add that we have to think about EOSC not as a centralized, very complex and deep system. On the contrary, it should be a very thin layer that is on top of existing infrastructure that can be sophisticated, deep and specific. What we are looking for is the minimum thin layer that will allow this federation of existing infrastructures, because we have already a lot of things existing in Europe. What needs is the federation. What we need is what will allow information to flow from one system to another one. And that's why the analogy with the history of the internet and the TCP/IP story is very applicable to EOSC.
Okay, we have a couple last questions. For instance, this last but one question. It's quite not technical, but I should say philosophical.
Sociological indeed.
Yeah.
I would say now, from this is again exactly what I said in my presentation earlier.
Okay.
From my perspective, I always think that technological things are easy to solve because I don't solve them. Somebody else does it. But I do think they are still, in some sense, easier than to get everybody to agree on things. This is much more difficult from that perspective, because there's so many different stakeholders, different funders, different levels of administration and region and scientists and research research performing organizations and all these kind of things. And for all of them to agree how they connect to EOSC, how they make it to work, or making some sort of structure that they can join if they want, and it's open enough that people can join and so on. I think that's going to be really the big challenge.
Okay, so maybe
We said at the beginning of Go Fair, the saying that it's 80% social and 20% technical.
No.
That's how we felt.
okay. Well, I think we can conclude with this last question.
We received answer on this question before.
What
to do?
probably, maybe
Say.
maybe partially. Yeah. I suppose that we have heard some answers to this question, but concerning steps in Russian Federation that we, all this Russian society, should undertake to probably share data with the European Union or to use data from European Union. So you, in your presentations and in your comments, you probably mentioned some ways. For instance, this proposing some implementation network in some subject domain, but probably you can comment some more steps that you have in mind.
Well, I think it would be excellent if some Russian scientists get the possibility to participate in EOSC events, especially the stakeholder forum that are coming in the pipeline, because we need to have to consult widely, because implementing an infrastructure for open science and fair data concerns everybody. So I think we need to hear the Russian voice in our stakeholders event. It would be helpful in both directions. I think it's a mutual collaboration that we are looking for.
So, Michelle, so the Austrian presidency happens in November 22, I guess.
23rd.
23. Are there any representatives at such events from outside Europe?
Could
Yeah.
not answer. This is
Yeah.
really organized by the Austrians, so I don't know. I haven't.
So I don't know, maybe there are some non-European observers from other places. It would be, because I know EOSC is a prominent feature of the Austrian agenda.
Sure.
Are there any announcement about this event, 23rd of November? Internet site or something like that?
Yes, but on the 23rd of November, it's an invitation only. This is a political event with the presence of some ministers, so it's rather restricted. Before this, the 23rd, you have 2 days with a stakeholder forum of EOSC, which is more, let's say, technical than political. But we also need to hear your technical voice.
Perhaps if this information will be available,
Yes.
it would be possible to try to enter this governmental level
Yes.
for this, and perhaps on the top level it will be possible to organize technical support and technical participation.
I think the idea, I very much welcome the idea. I was not thinking about this event in November this year because it's very soon. I was thinking about future events of the stakeholder forum, and there we have more time to prepare a strong participation, as strong as possible.
We must push our top level and government level for this.
And of course, one other aspect which you can think of, it depends on the field of science. For example, in the case of environment, in this cluster project that I presented, we are organizing also this kind of stakeholder activities, which are then more discipline oriented. So if you are exactly looking what is inside your discipline is the interoperability, what we are thinking for it. The places where we were planning these ones, for example, environmental sciences are the European geosciences meeting, EGU every year in Vienna, and then one in USA, the AGU actually, which you mentioned, they have a plenary every year in December in US. And this kind of activity we were thinking. But of course we can maybe think about even more wider. And of course everything what we do in these kind of projects, at least I'm not promising for all the projects, but at least the projects which I am in, is that everything is always open. Anything what we create is immediately open and available for comments. This is how we think things should be run.
Okay, one thing for Alexander.
The question is, what do you recommend us in that case? Our resources integrated in virtual atomic and molecular data center located in Paris.
Sorry, I did not hear. Excuse me.
Our resources,
Yes,
spectroscope resources,
yes.
integrated in information system, virtual atomic and molecular data system, data center, excuse me. The center localized in Paris, and we have 4 nodes in Russia integrated in that system. Does it mean that we have to follow your recommendation and reformat our data?
You mean in the case your nodes would like to contribute data to EOSC or?
At that time, it's formatted during the standards of this virtual atomic molecular data. We have a standard XML schema for this structure of this data. And the history of this virtual center is more than 10 years. The question have we to reformat this data in the standard of the fair data. What's your opinion?
I think in EOSC we have rules of participation, and this will explain in a way how you can contribute to EOSC. I think these are not yet defined. We have some ideas, and there will be a specific expert group analyzing what these rules could be. Now that we have a governance in place for the next 2 years, there will be also a way to decide on those rules of participation. So once this will be clear, I think by 2020 we will be able to much better address who contributes what to EOSC, including, for instance, from your community and the nodes that you are speaking about.
Thank you.
Okay, so do we have any more questions?
No.
Okay. Okay, I think we have to conclude our session and to gratefully thank all the invited speakers.
Here.
So and and last, maybe last but not least thing, Vladimir would like to make the photo with all the people who participated in this workshop. So, so everybody please.